To print or not to print? That is the question. Hello and welcome to Taboretum channel. Halloween is coming, so I thought today we'll talk about how to quickly print a skull. This is the more Halloween one, and this is the more serious one. And we will talk how to slice such a thing effectively to print it not in 25 hours or more, but in 10, maybe less. Let's get to the PrusaSlicer and get it done. Okay, so here we are in the PrusaSlicer 293, and as you can see, this skull is slightly outside. So what I will do first, I will rotate it a bit in Z-axis, like 45 degrees. And as you can see now, if we move it a bit, or we ask it to arrange, yeah, it fits now, it became green, so we can print it. We could print it. And if we slice it in a super draft mode, well, let's do it maybe not super draft, but normal mode. Let's slice it. And let's see what's the time. We lack supports. There are a few places where this skull is actually start printing mid-air, so we need to add supports, and we'll be using organic supports. I'm a big fan of organic supports, you know, these kind of a tree shape. They don't use that much filament, and they look nice, they actually break off nicely and so on. So let's see where we are. Yeah, we have stability issues because it's not flat at the bottom. I still have infill like 15%, but these are the default values for Ender 5 with 0.4 nozzle. And it says it will use 150 grams of filament and it will take 1 day, 8 hours. So 32 hours, roughly, 32 hours. So, and there are no supports yet. So first thing I will do, I will switch to my presets of Ender 5 with 0.6 nozzle. And let's see what's the difference. It was 32 hours. Should be better now. Not perfect, but better. Generating infill. We'll get rid of an infill in a second. And I will also show you how to easily figure out where you are spending time. Yeah, we still have warning. Generating G-code. It takes time because it's a huge model. Remember, 32 hours. That was the first shot at it. Yeah. And you can see, well, yeah, it just, and now it's 15 hours. So you see, it's half of it if just using the 0.2 millimeter wider nozzle. And let's see what else we can do. You can see here that we are spending 2 hours on perimeters and 6 hours on external perimeters, which means we have perimeters inside. Right, so we can turn them off because if you look at this model, this yellowish thing inside is not really needed there. So we can say we don't want it, but we want it at the very bottom. So first of all, let's sync it a bit so it is stable. We probably want to sync it relatively object coordinates because it's easier in Z. We move it down by 0.2 millimeter. Let's see how deep we are. We're probably not deep enough yet. Minus 0.2 more. Yeah, you see we are touching a bit. We probably could also rotate it a bit, but let's just add minus 0.2 more. Yeah. Yeah, and let's rotate it in, I don't know which axis. Let's see, because you know it is the object coordinates. So yeah, we can see now which. And I thought about actually these axes, not this one, and let's make it minus 0.1%. Yeah, it's moving to the front, but probably too much. Yeah, so let's get back. Minus 0.5. Oh, plus 0.1 now. 0.1. 0.5. 0.5. Yeah, 0.3. No, too much. Or was it 3? Yeah, it was 3. 0.3. Okay, and 0.1 minus 0.1. Okay, and in Z still minus 0.2. Okay, and you can see we are touching probably enough so it sticks. Maybe there is still a gap here, maybe even a bit more. Minus 0.1 more. Okay, I think it should be stable now. Now the next, and it says syncing. Now the thing I mentioned, we go to print settings and we say vertical shells will be good with 1 perimeter. Why not? Platter slice. Now we have proper bottom, so it should stick to the build plate. Plus we don't have this internal infill, and I will also change the infill to 0 in the meantime, but let's slice it with infill 0. Yeah, and we don't want feature type again. So now you can see that we have solid infill and we have external perimeter, and in total we are now at 17 hours. Yeah, so let's get rid. So you can see there is a solid infill, and this infill is actually not part of the perimeters but part of the top and bottom layers. So we go back to print settings and we say that we also don't want top and bottom layers. I don't know why this value is so huge. We say 1 and 1. The only problem will be at the very bottom and the very top. So actually we'll do differently. We'll say 3 here and 3 here. But now we'll get back to the platter. We'll add a modifier. We'll say add height range modifier, and we'll say that, you see the whole thing is 150 millimeters. That's starting from millimeter 1 up to millimeter 149. We want a modifier. So for the majority of the skull we want a modifier, and this modifier will be to set perimeters, we have 1, to set bottom and top layers to just 1 and slice. So now what's gonna happen, we will have only the shell of these tiny elements printed, and this should actually save both filament and printing time. And honestly, I managed to get down to 9-ish hours. So let's see where we get here. And you also need to remember that this is the estimate from the slicer. It not necessarily needs to be exactly the same thing when you print the file. In my case, I'm using, for example, firmware retraction. So I said in the printer itself what's the retraction speed, length, and so on. So Slicer does not have even the possibility to estimate that. And you see, we are at 10 hours 30 minutes now instead of 32 hours. And if you look now close here, you can see that we don't have this inside crop, but we have enough at the bottom so it sticks. And then we just print the empty shell plus some extra infill bridges in places where it needs it to build the thing. Now what we need to do, we need to do the support painting. So if we are here again, you can see, looking from the top, that are places where we start to print mid-air. And these places are here. You can see this island here. So we need to support this place. Plus the jaw here. You see? So we need support basically these 2 points. So we get back to the model. We select the model and we get to paint on supports. And important thing, we need a circle, not a sphere, because this is a very azure model, and if we'll be using sphere, we can paint on the inside part of it, which we don't want. We look at the bottom of it. We can make this brush smaller, and we can check this is the place that we need to support. Right, this thing is mid-air, so we say we only paint this one over here, and we paint analog moment here, which is here. Whoops, Control Z works. Yeah, plus this is this tiny thing that we wanted to support, and we go to the print settings. Support material, and we say generate support material, and the type of style, well, style is here, we want organic, and let's slice it now. We can turn it back. I'll grab the big one in the meantime. It's back behind me. You see? Am I similar? Here's the thing. Nice and, well, not shiny actually. Printed in 9 hours, which is not that long. It's smaller than my skull actually, but not like a child's skull size, let's say. And only with these 3 supporting points. So let's get back to the slicer. It's still generating the support material. It is super slow. Oh Jesus, what happened here? Something terrible happened. If you want to keep both us awake and motivated, you can buy us a coffee. There's a link down there. And if you like the content, please subscribe, hit the bell, like button. Thanks. I know what happened here. Okay. So in the print settings, in the support, I said our auto-generated supports. We don't want that. So it supported everything that is hanging. So it was trying to support the whole thing. So let's slice it again. Now it should be just these few points. We should see three trees supporting these mid-air prints. Yeah, you can see 1, 2, and 3. And the print time is now What is the print time? Okay, it's still generating the G-code. That's why we don't know what's the print time. I'm too optimistic. So print time now is 11 hours. And we see that majority of this time is the external parameters, which is good. And now what we are going to do, we go to speed and we push it, and we can push it quite a lot. And yeah, and I know now what's okay. We've been using some not the best preset, so we can switch to we transfer what we set before, but the speeds are higher, and we will make them even double what we have here. So we say 60 here, 60 here. Some of these numbers doesn't really matter because we don't have infill, but just to be consistent, let's make everything double. Bridges will stay with bridges slower, and we also want to keep the first layer slow, and we have travel at 120. And now if we get here and slice again, we'll be close to our goal. So let's wait and see. And I'm redoing it, as you can see, in a different version of Slicer on a different machine, different operating system. That's why I struggle a bit. But the thing is, you limit number of parameters. That's one. Then the second thing is you also limit the number of top and bottom layers to avoid this extra plastic inside of it. That was the second thing. Third thing is you actually increase speed. Fourth thing, you use smart supports, which are the organic supports, and you should end up with a nice print like this. Now we are generating support material here, and in a second, yeah, and now generating G-code. And now it says 99 grams of filament and 9 hours 39 minutes, which means that we are 3 times faster than the default thing on the default settings on Ender 5. So I hope you enjoyed it. Maybe you will use these tricks on other prints, and happy Halloween. Thank you very much. Bye bye.